So today we get to go on to our next section of 1-3. And we get to talk a little bit more about graphs and looking at our fancy graphs and figuring out some key little points of like when graphs are increasing or when graphs are decreasing or where they're staying the same. So some exciting news is coming your way today. So we got section 1-3, and it's a very fancy title of More on Functions and Their Graphs. I almost ran out of room. So I'm going to draw a beautiful graph. So we have our x-axis. And then on our y-axis, like we don't have to start at 0. So a lot of times if you're looking at like one of your axes and you want like a break in there, you just kind of, like when you're drawing it up, you just kind of, whoa, hey. Why did it, I'm going to try this again. When you draw it up, you just kind of draw like a little squiggly. And that just means like that you're not starting at 0, you're starting at like some other number. So for poops and giggles, I'm going to start at like 98, 99, 100, 101, and like 102. And on the bottom, I don't know, we'll just go with a 1, a 2, a 3, a 4, a 5, a 6, and a 7. And I'm going to say this is like hours after 8 a.m. And this is the temperature outside. We'll say it's in degrees Fahrenheit, because if it was Celsius, we'd really be on fire, wouldn't we? So our graph doesn't have to be perfect, but I'm going to throw some points in here. So I'm going to go kind of like at like 3, 98, at 0, 101, and at 5, 99. And then on my little function, I'm going to bring this down and group it, and then I'm going to go straight. So not that it's got to be perfect, but it's close. I think that might work a little better. All right. So if we were to kind of, tell a little story about our graph. So at 8 a.m., what was the temperature? Would 8 a.m. be over here, or would it be right here? It would be right here, right? Because this is hours after 8 a.m. So at 8 in the morning, the temperature outside was 101. And then what did it start to do? It started to decrease. It decreased until what time? What's this going to represent? If this is 8, right, this would be 9, 10, 11. So at, we can even, right? So we know that at 11 a.m., our temperature was what, 98 degrees? Whoops. Okay. And then after 11 a.m., it started to increase in temperature until what time? Till 1, right? And then at 1 p.m., the temperature was 99 degrees. And from 1, 2 to 3, and later, what did it do? It stayed a constant temperature of like 98 degrees, right? You guys can tell those cute little stories? All right. So we want to be able to kind of write some of this a little bit more mathematical. And we talk about when the graph is decreasing, when the graph is increasing, and when it's staying constant. So when we're talking about those increases and decreases and staying constant, we're looking at our y values, right? So like, our y values are decreasing until we got to this point, and then they started to increase, and then they stayed constant. So we want to be able to define where our graph is decreasing. So if we're talking about decreasing, we're decreasing from here to here. Right? So we're decreasing when our x is from 0 to 3. So, we'll just throw it over here. So if we want to talk about decreasing, we're just going to throw this in like little parentheses. So we're looking at our x values, and we started to decrease when our x value was 0. And we continued to decrease until our x value was 3. And then after we decreased, we decided to increase. And at what value did we start to increase at? 3. And we continued to increase until we got to 5. So from 3 to 5. And then we stayed constant. I'm going to help us out a little bit. We're going to throw an 8 on there. Whoops. And then put a little dot at 8. Just so that our graph ends. So we don't go to infinity, because we know that it's not going to stay 99 degrees forever. Okay? And then we started with a constant temperature. And when did we start being constant? At 5. And we continued to be constant until we got to 8. So then we're constant from 5 until 8. Not too shabs, right? All right. Ready to try another fun one? I'm all about fun today. Get some pages going on in here. There we go. Let's go with cute little XY coordinate. And I'm going to go whoop. And we'll go, I don't know, how high you want to go. 1, 2, 3. You tell me when to stop. 3, 4, 5. Good job. Good job. And then tell me when to stop going over. Good job, good job, good job. I like it, I like it. Right. So let's go. I'm going to put a dot right there. So at what? 2, 1, 2, 3, 4, 5. At 2, 5. So then I'm going to bring my graph up, and then I'm going to go back down. Just to hopefully give you guys a little bit more of a reference point. So on this graph, just in cheesy words, because we're always going to read like a book, right? Just like in English, we read from left to right. So when it comes to reading this graph, we're going to start at this side, and we're going to stop over here. Right? So if I start right here, I'm going which way? I'm going down, so I'm decreasing until I get to the origin, and then what do? I increase till I get to some point, and then I decrease. Okay? So we might as well start with the old decrease. Whoop. So at what value do we start decreasing at? What x value? Because this guy technically goes forever and ever and ever. So we got to find this x value over here. So if I'm looking at my negative x's, what's the smallest negative x value that this graph starts at? Negative infinity. Yep, good job. Right. And then I'm going to continue to decrease until I get to when my x is 0. And then at 0, my fancy little graph is going to start to increase. And I'm going to continue to increase until my x value is 2. And then I'm going to decrease again, starting at 2. Okay. And then I'm going to continue to decrease until my x value is positive infinity. Oh. Think you guys are good on figuring these ones out? Yes. Well, my y value is at 5, right? But when I'm looking for where I'm increasing and decreasing, that's me going along the x-axis. Because when this one, how this one is, like over here we're decreasing, right? Well, we started decreasing at negative infinity, and we continued to keep decreasing until we got to 0. And then once we got to 0, we kept increasing until we got to 2. And then once we got to 2, we started to decrease until we got to negative infinity. Does that make sense? It's almost like, think of your x-axis as being like a timeline, right? And that's what you're going by. Need another one, or you think you're good on the graphs? You guys are good on the graphs? All right. So in math, we like to be able to look at equations or look at functions and kind of be able to determine, like, hey, because I see that my exponent is 1 on my variable, I know that it's going to be a line. Or if I know that my highest exponent is squared, I know it's going to be some kind of quadratic, to where we don't have to graph everything, but it kind of gives us like an overall description of what's going on. So sometimes you guys always thought that we were like super smart as teachers, because we'd be like, oh yeah, that graph is going to look like this and this and this. And you're like, how did you do that? Like, I got to plot the points, or I got to graph it to know. So our equations tell us a lot of information. And one of the things it tells us when it comes to our functions is it tells us if they're even or odd. So let's look at some even or odd functions. And when we're talking about even and odd functions, we're looking for symmetry. You guys know what symmetry is? It's kind of like that mirror reflection somehow or another, right? So when it comes to our even functions, our even functions have symmetry with respect to the y-axis. So these ones have symmetry to the y-axis. So an example would be if we have our little xy plane. Here's our y-axis. So whatever it looks like on the left side, it's going to look just like that on the right side. So the easiest and cheesiest example would be a nice little simple quadratic. Those would be like our even functions. And if it's not even, it's going to be either odd, or it could be neither. But so when it comes to our odd functions, Odd functions are said to have symmetry with respect to the origin. So symmetry, we'll just say to the origin. So if we had our cute little x, y coordinate plane. So symmetry, when it comes to the origin, it's ultimately, if it flips over the origin, it's going to look the same on either side. So it would look kind of like this. Okay. To where if I took just this piece and I flipped it over the origin, because to flip it over the origin, I'd have to like go over x and over y, it would flip it down here. And then the third thing would be like neither. So neither means it has no symmetry, right? So if you got your x and y coordinate, let's say your function went something like that, right? Oops. That guy doesn't have any symmetry, does he? So you can get functions where they're not either even or odd. So now the big question is, how do you determine if they're even or odd? So let's start with an equation or a function. We'll start with some evens. So if we had this nice cute little f of x equals, let's say, x to the fourth minus 2x squared. We know it's a fourth degree polynomial type thing. So we want to know that when we graph this, if this is going to have any symmetry to it. So what you do, wherever there's an x, you want to sit there and put in negative x. So this is going to give me what? Negative x to the fourth minus 2 times negative x squared. And then we're going to try and simplify it. And then when we simplify it, we get x to the fourth. Oops, I'm a dork. Minus 2x squared. And what do we notice about the original and when we put in negative x? Guess what happened? They're the same. So if you put in negative x and they come out the same, that's telling you that it's going to be an even function. So what that tells me is just very generically that if I had my nice little xy coordinate plane, I'm going to be symmetric around the y-axis. So I know that I'm going to look something like, oops, I'm a dork. I'm going to look something like this. Just generically speaking. Now granted, I know that my x-intercepts or my y-intercepts aren't accurate, but at least gives me a general idea of how I know that that graph is going to look, because I know that it's going to be symmetric to the y-axis. So then if it comes to odd, so let's say we had f of x equals x to the third minus 6x. So we're going to do the same thing. What are we going to put in for x? We're going to put in negative x. So negative x to the third minus 6 times negative x. And then now we're going to simplify. We get what? Negative x to the third plus 6x. So when I look at these two equations, the original and the negative x, do you notice anything about them? The sign switched. Yep, absolutely. So we even read, right? So this one, the signs switched. And if our signs switch and every single one of them, the sign switches, then we know that it's going to be an odd. So we know then if we were to graph that one, it would be symmetric around the origin. So it's going to look something like this. Okay. And even, these were equal, right? So we can even add that up here on our little thing, right? So this is telling us that f of x equaled f of negative x, right? And then when it came to our odd functions, the way you would write it, it would be f of x equals, if I wanted to change the sign of everything and multiply by negative, so it would be negative f of x. All right, you got to try one for me. So you guys try, oops, let's say f of x equals x squared plus 2x plus 1. So to find out if it's either even, odd, or neither, what are you going to do? F of negative x. And you guys need to tell me. Come up with an answer. Let me know if it's, we'll take a vote. Is it even? Is it odd? Or is it neither? How many of you guys think it's even? How many of you think it's odd? How many of you think it's neither? Yeah. So we'll go through them real quick. To be even, they have to match up exactly. And does this one and this one match up exactly? Nope, because you got the positive and the negative, right? So it can't be even because they don't match up exactly. To be odd, what has to happen? Every one of the signs need to change. So positive, positive. So right there tells you that it's not going to be odd. The second one changed, but the third one didn't change. So the first and third didn't change. So it can't be odd. Oh, yeah, cross these babies out. Can't be even, it can't be odd. So if it's not exactly the same and all of the signs didn't change, it would be neither. All right. Good? All right. I think I gave you guys, I don't even know. I don't even have it on the sheet. Do I? 1, 2, 3, 4, 5, 6, 7, I think 8 problems to work on for today. So the first couple ones are going to be looking at a graph and then writing down where it's increasing, decreasing, or staying constant. And then the second half of those are going to be determining if it's an even, an odd, or a neither function.